Okay, so lecture 3.4, the greenhouse effect. So all of these module lectures this week are kind of building up to um, it taking this concept of climate change. What is climate change? Why is it happening? How is it happening? And trying to break it up into little chunks so that by the time you worked your way through all of the modules and all of the lectures in the module, hopefully you have a broader understanding of climate change. So this lecture is a shorter lecture, and it really is just helping to reiterate again what is the greenhouse effect and what is the enhanced greenhouse effect and its causes. We just have three key terms today: atmosphere, greenhouse effect, and human enhanced greenhouse effect. So the Earth's atmosphere is where greenhouse gases are, where they come into the picture in terms of climate change. And it's really the Earth's atmosphere that is driving, where the processes are happening that are driving climate change. So our atmosphere is made up of gases, and these gases play very important roles in a number of processes and life supporting services on Earth. These gases regulate the heat and the energy of the Earth and the climate of our Earth. They also regulate and factor into weather and other natural processes. So the bulk of our atmosphere is nitrogen and oxygen. And the bulk of that is actually nitrogen. So 78% of our atmosphere is nitrogen, 21% of it is oxygen. Nitrogen and oxygen are not greenhouse gases. They do not play a role in climate change, in global warming, and so they are not of concern when it comes to climate change. And in fact, greenhouse gases like carbon dioxide, water vapor, other gases make up a very, very small percentage of our total atmosphere. So in some ways, it's kind of surprising that these gases are so problematic, because they are such a, when you look at the total breakdown of our atmosphere, a very insignificant part of what our atmosphere is made up of. Also, just want to make sure that everybody is aware that our atmosphere is not just the clouds and the bit of air that is above our clouds. Our atmosphere starts at the surface of the Earth. So the air that we walk around in every day is part of our atmosphere and extends for about 300 miles outward from the surface of the Earth. And then there is sort of this invisible boundary between our atmosphere and outer space. Our atmosphere is divided into 5 main layers, 4 of which are depicted here on the figure. We have our exosphere, the thermosphere, the mesosphere, the stratosphere, and the troposphere. You do not need to worry about memorizing those different layers of the atmosphere, but just want to cover briefly what those layers are and what they do, because it is helpful when we then start to talk about greenhouse gases and what they're doing in the atmosphere. The atmosphere gets thinner and thinner as we move from the surface up into outer space, because the gases are dissipating. So there are fewer gases in the thermosphere than there are in the troposphere, obviously. Much less oxygen, much less nitrogen. That's why when we are in the upper layers of the atmosphere, we cannot breathe without oxygen, an oxygen tank. There's no distinct boundary between Earth's atmosphere and outer space. There is sort of an imaginary line that scientists say is about 68 miles out, where they usually say that's where the atmosphere meets outer space. But it's not like there is a distinct, okay, now we're in the atmosphere, now we're out of the atmosphere. The troposphere is that layer that is closest to Earth's surface. It's about 4 to 12 miles thick and half of the Earth's atmosphere. So half of all the gases in our atmosphere are in that troposphere layer. It's a layer where the air is warmer nearer to the ground and it gets colder the higher we go up. Nearly all of the water vapor and dust in our atmosphere are in this layer, and that's why this is the layer where all of our clouds are found. The stratosphere is the next layer out. It obviously starts right above the troposphere. This is the layer of our atmosphere where our ozone is most abundant. This is the layer that is, I guess you could say, responsible for heating our atmosphere while also absorbing harmful radiation. So, ozone is a gas, O3, that actually absorbs the most harmful radiation, the ultraviolet radiation that comes from the sun, and protects our skin from those harmful rays. The air in this layer is very dry. There's no water vapor in here. It's very thin. We cannot breathe at this layer. But it's also of that, because of that, that's where jets fly. Because it's thin, they can fly faster and without the turbulence. So you get up into the stratosphere if you are going on long distance air flights. The mesosphere is the next layer up. It's the coldest part of our atmosphere. Temperatures get to be about minus 130 degrees Fahrenheit up here. This layer is actually a very hard layer to study. Scientists don't know a lot about it. Jets can't go up here. Balloons don't go high enough. Satellites and our space shuttles are actually above the mesosphere layer, too far above to really know much about what's going up here. What we do know actually, though, is this is the layer of the atmosphere where if a meteor comes into our atmosphere, it's going to burn up at this layer. And then finally, we have the thermosphere. This is the thickest outermost layer. It's still considered to be part of Earth's atmosphere, but air density up here is so low that most of this layer is what scientists would be considered to be outer space. And this is actually the layer of our atmosphere where the space shuttles flew and where our International Space Station orbits the Earth. And then the exosphere, that highest layer not shown on this figure, is extremely thin, and it's really just where the atmosphere is merging into outer space. And there's some hydrogen and some helium up here, and that's really about it. So that's our atmosphere, and sort of the makeup at the various different layers. Sorry, is the burning of fossil fuels, coal, natural gas, and oil. And scientists are confident that this burning is a major contributor to the enhanced greenhouse effect. We produce emissions daily. We drive cars, which release carbon dioxide emissions. We generate electricity, and if we are burning coal to generate that electricity, we are, as a byproduct of burning coal, releasing carbon dioxide into the atmosphere. All of these things are enhancing the greenhouse effect. They're putting more carbon dioxide, more methane, more ozone, other greenhouse gases into our atmosphere, which means there are more of these gases that are trapping more of the heat on the planet. This extra heat causes the global warming and affects our weather patterns as well. So I think this illustration right here is a really good illustration of we have a natural greenhouse effect, where the sun shines, solar radiation and energy comes to the earth. It Some of it's absorbed by the earth, some of it's reflected back out into the atmosphere and into space. Some of it makes its way through the atmosphere and back into space. Some of it is trapped by the greenhouse gases and returned back to the earth to heat the earth. When we enhance the greenhouse effect through human behaviors, we get more of the carbon dioxide, more of the methane, more of the nitrous oxides and other greenhouse gases, trapping more of that heat and allowing less of it to escape into space. So the burning um, of gases is one of the contributors to this. So carbon dioxide, methane, nitrous oxide, fluorinated gas levels, those are all greenhouse gases, and I will in next lecture go over those in a little bit more. How What human activities are actually releasing these gases into the air? Well, I've talked about one already, the burning of fossil fuels. Every time we burn natural gas, coal, and oil, we add large quantities of carbon dioxide into our atmosphere. We use fossil fuels, we burn fossil fuels to produce our electricity, to drive our cars, and all industrial production. So we use a lot of fossil fuels every day. Farming practices, though, also enhance the are another cause of the human enhanced greenhouse effect. When we use a lot of fertilization in the soil, that has led to increases in methane and nitrous oxides. But more importantly, animals release a lot of methane um, through just through a byproduct of their wastes. So cows, sheep, other agricultural animals have really enhanced the amount of methane in our atmosphere. Industry processes also produce and emit greenhouse gases, such as hydrofluorocarbons and sulfurs, and these are, specifically sulfur hexafluoride, but these are very strong greenhouse gases that can be very potent. And then finally, deforestation also enhances the human enhanced greenhouse effect. The more trees we cut down, the less trees we have to absorb carbon dioxide from the atmosphere and through the photosynthesis process. And so if we have fewer trees, we have fewer trees doing those processes, and so there's more carbon dioxide staying in the atmosphere. So that's a brief summary of the natural greenhouse effect, which is good, the human enhanced greenhouse effect, which is bad. And in the next lecture, I will be going over what are greenhouse gases and how exactly it is that a greenhouse gas traps gases in our atmosphere when things like oxygen and nitrogen do not.